Hi guys, it's been a while since I have last posted in this channel. But rest assured, I will be regular from now onwards, and I will be posting about Fusion 360, mechanical engineering, manufacturing engineering, and obviously industrial engineering also. So in this lecture, we will start with constraints in Autodesk Fusion 360. And this lecture would be an integral part of a series that I'm going to make about different tips and tricks of Fusion 360, some hidden things that most of the people don't know, uh, and certain basic things. Everything, almost everything will be covered. But if you want a bit deeper insights about Fusion 360, and if you want to get a certification in the same, you can take my course. The link for the same is in the description. Okay, so let's just begin with constraint. So basically, what is a constraint? A constraint is what? Constraint is restriction. Constraint is like putting a particular limit about particular set of objects. In Autodesk Fusion 360, constraint is something that controls the relative motion between one object and another. So for the same, I have made certain sketches which will help you understand all the types of constraints in Autodesk Fusion 360. So the constraint toolbar is over here. As you can see, the first constraint is the horizontal and vertical constraint. As the name suggests, it makes the sketch entirety horizontal or vertical as per the axis is concerned. Let's invoke this constraint, and let's say we are selecting this particular line over here. As you can see, it became perpendicular to the x-axis. This is the sign of the constant. It's a vertical constant. Now let's select this particular line, and it will become perpendicular to y-axis. So basically it became a horizontal constant. So perpendicular to x-axis is what? It's let's press exit button so that you can get out. For getting out of any of the tool, just press the exit button. Okay. Yeah. So now here, as you can see, this particular symbol, it means it's perpendicular to the x-axis and it's a vertical constraint. And here it's perpendicular to the y-axis and it's a horizontal constraint. Okay. Next we will go to coincident. So basically, it will coincide one particular point to another line, or one line to another particular point. Let's say, for example, I'm selecting this point and I'm selecting this particular line. So this circle will become coincident to this line. Now, when I click on the circle and I try to drag it, it will drag in and out. Its diameter will change. But when I select the point which is coinciding with the line, and I try to drag it, it will be dragged along the line itself because it's coinciding with the line. Got it? So next would be tangent, as the name suggests. It depicts tangency constraint. So when we invoke this particular constraint, this particular tool of constraint, and let's say, for example, we are selecting this particular line and this particular circle, it will become tangent to it. And this omega like symbol is the tangency uh, denotion of constraint. So basically, what is a tangent constraint? It means that these 2 points will touch only once and they will never touch ever again. So if I'm dragging this line over here, As you can see, tangency is maintained, but this particular circle is also moving with the line. So the next would be equal constraint. As the name suggests, it will make two objects similar to each other, equal to each other. So let's invoke it. So if I am selecting this circle and this circle, so what will become? Both will become equal to each other. Now the good part is, if we are changing size, if we are dragging, if we are selecting any one of the circle and we are dragging them in and out, another one, the other one will also change. The size of other one will also change. Same thing here also. See. So this is the best part of the equal constraint. Okay. Next would be parallel. Obviously, as the name suggests, let's say, for example, I'm selecting this line and let's select this line. So it will become parallel to this. These two became parallel. Then we have perpendicular. Obviously, same thing. Let's select this and select this. They will become perpendicular. So this line and this line is now perpendicular, and this is the symbol denotion of the same. Now comes a very uh, like useful kind of constraint, that is fix or unfix. To understand that, let's undo the last one. Just press Ctrl Z in the keyboard. So now here, earlier we made a tangency constraint between this curve and this particular line. So what was the tangency constraint? Tangency constraint was between a curvature and a line in which they will intersect only once, and then they will never intersect with each other. So now if I'm dragging this line, this circle is also changing accordingly, and this circle is also changing because both are equal. So let's delete this one so that there should be no confusion about it. Now if I'm invoking the fix constraint, and let's say I'm selecting this circle, first thing that we can see here is that the circle's becoming green in color. And when I am dragging this line now the circle will not at all change its size or anything. So this is what fix and unfix constraint is. Next comes midpoint. Obviously, as the name suggests, it creates a constraint between a line and another sketch entity with respect to the midpoint of the selected entity. Let's say, for example, I'm selecting this particular uh, line over here, and let's say I'm selecting this line. Okay. So now this line, earlier it was here. Now it came to the midpoint of this particular line of this particular rectangle. Next we have concentric. For that, let's make another circle somewhere here. C is the shortcut for circle. You just press C in the keyboard and you can invoke circle command. So now let's invoke concentric constraint. Let's select the circle and let's select this particular curvature over here. And as you can see, they will become concentric. Now, if I am selecting it again and I am selecting this one, the whole thing comes here. Let's select this also and select this. See. So basically, the uses of certain constraints, certain tools in a systematic manner can drastically change your sketch expertise. So you need to find a mix of certain tools that you can have your expertise with, and you can have a mix of certain constraint to go with certain tools, and you can like do wonders with Fusion 360. All right. So next one is collinear. So basically it makes two objects sketch entities collinear. So they will be like on the same line. and it obviously changes the shape. So let's control Z to that. Let's make it again. Let's make a fresh one. Let's make a fresh line and let's understand this collinear constraint. Let's invoke it. Let's select this line and let's select this line. See, this is what collinear constraint is. Like it makes two sketch entities to remain in a same line. Then we have curvature. For curvature, we need to make a small sketch. Let's make a rectangle over here, a triangle or triangle. Let's make another line. All right. And let's make a fit point spline from this particular point to this particular point. Just press enter. So now we have these two control points over here. We are not touching anything. It's like a line only, but it's a spline. So what we will do, we will make a curvature. So basically it creates a smooth and continuous curvature between two sketch entities. So its job is to create a rule that two sketch entities will have a smooth curvature between each other. So let's say, for example, I'm selecting this spline and this line. See, it's a very smooth curvature that is coming. It's denoted by this particular sign and a very smooth curvature came. So there is no overlapping, nothing, a smooth curvature. Now, if you ask me, like, is it possible between two lines? The answer would be no. Let's say, for example, I'm again selecting this. Let's select this line and try to select any other line. No, it will not happen. It will happen with a particular curvature or a spline. Yeah, I guess this is it for constraints. I will be coming back with another lecture. So stay tuned. Thank you so much.